The topic is variation functions. Go ahead and write the topic down. Don't need to write the objective. The objective today is to solve problems using direct, inverse, and joint variation. On the next slide, there are some formulas that you do need to write down. They're very important. The first one is when you have a expression like y varies directly as x. Then you want to set up an equation. It's called a direct variation equation. And I did highlight the word direct. Let's write it again off to the side. You use the equation y equals kx, where k represents the constant, and then y and x are the two variables. The next expression is when y varies jointly as x and z. So the equation you would use is y equals kz. The big word there for you to notice is the word joint. And then the last equation with the expression y varies inversely, so that's going to be a fraction, y equals k divided by x. And the big word there for you to notice is the word inverse. So give yourself some time to write that up, and then we'll go ahead and solve some equations using those three formulas in the blue, green, and red. All right, the first thing is, don't write this slide down, what is the definition of direct variation? There's a long definition. It says the variable y varies directly as x if there's a non-zero constant such that k equals y equals kx. You already have that formula, but just wanted to give you clarification. The problem that I want you to write down is this. I'll highlight the pieces I want you to write down. Go ahead and write the example and write the word direct variation. And here's what we're given. Write the given down. Y equals negative 24 and x equals 4. So go ahead and write down those two highlighted blue pieces. And then notice the words here. Y varies directly with x. In quotes. We are going to go ahead and set up a variation equation. So I'm going to take this problem a little bit slower than the next examples just because it's the first time you've seen it. So the first thing you do is you identify which of the three formulas. So in this case it's a direct variation. So part A is direct variation equation, which was on that slide, the three formulas. And this is the formula y equals kx. Then what you do is you substitute in the given negative 24, so that goes in for y, and then the given x, which goes in for the x. So the substitution would look like negative 24 equals k times 4. So there's step one, as you set up the direct variation equation, and you substitute in the given values. In this case, we have a given x and a given y. Part B is to go ahead and solve for k. So step B, go ahead and underline that. Part B is to solve this blue equation up above in part A for k. So we're going to solve for k. So I'm just going to rewrite the equation. Negative 24 equals k times 4 is 4k. Now we have to get that k by itself, so we want to undo the 4 times k. So to undo that, we divide it. So we divide both sides by 4. The 4's will cancel. And then negative 24 divided by 4 is negative 6. So what we just found is what we call the constant of variation, k. Part C is to go out and rewrite the equation with the constant there. So the original equation was y equals kx. All we want to do in this step is to replace it with the k. So your answer in this question is y equals negative 6x. So then you can go out afterwards and maybe solve for different values for x or y. Do know that this equation is a linear equation. The y-intercept is 0. The slope is negative 6. We can go out and graph this direct variation equation. It's a line. In our class, we're not going to do that in this section. They do teach it and show you in the textbook. You can do that if you're interested in looking at it in the book. The next one is joint variation. Y varies jointly as x and z. Don't need to write this down. The formula is y equals k times x times z. All right, so the next example. Y varies jointly as x and z. So that's what you're given. So I'm going to highlight this word, jointly. Y varies jointly as x and z. And then they go ahead and give us 3 variables this time. The y value, the x value, and the z value. So we're going to do the same thing as the last example. We're going to substitute in the y in, the x in, and the z in. So we have a little bit of time to go ahead and finish writing up what we have here on the smart board. So step 1 is identify what equation, in this case it's a joint variation, so it's this blue formula, and now we're going to go ahead and put the pieces in. So we have negative 324 goes in for y, k is our unknown, x is 5, and z is 9. The 3 pieces on the right are all multiplying each other. Part B, we're going to solve it for k. So I would first multiply 5 and 9 together, which is 45k. And then the next thing I would do is divide both sides by 45. The 45s will cancel. Negative 324 divided by 45 is negative 7.2. That is the value for the constant of variation k. Part C is to rewrite the constant of variation in the joint variation equation. So the general equation, again, remember, was y equals k x z. We just substitute that value in. Y equals negative 7.2 x z. Here is the definition of inverse variation. Don't need to write it down. Y varies inversely as x, so we use the formula y equals k over x. So this time we're given y varies inversely with x. So go ahead, underline that and write it down. And we're given that y equals 4 and x equals 5. We want to find that equation again. So we'll do those same 3 steps, step A, B, and C. On the next video, we're going to go ahead and do the word problem that will help you why we have to know direct, inverse, and joint variation. So we're going to substitute 4 in for y and 5 in for k. Sorry, for x. So 4 equals k divided by 5. Part B, we're going to solve it. So in this case, we have a 5 dividing k, so to undo that division, we do multiplication. So I'm just going to rewrite the fraction on the right and then the 4 on the left. And we have to multiply both sides by 5. So the 5's will cancel on the right, and then 4 times 5 is 20. Now we know the constant of variation k. Last step is to rewrite the equation with the k in it. So the general is y equals k over x. We're going to substitute 20 in. So our equation is y equals 20 over x. The next slide on the video will have a word problem. I'll stop the recording.